All right, starting 4-9 day 2. I have all 5 problems typed here. I did not leave enough space, so you'll have to put the work in your notebook. So we're just going to get started right in it. Related rates, problems, day 2. So our first one, we've got, I had a sand and gravel plant. Sand is falling off a conveyor and onto a conical pile, conical is the key word, at a rate of 10 cubic feet per minute. So this cubic feet is telling me something about the volume, how fast it's changing over time. So this is a volume derivative here. The diameter of the base of the cone is approximately 3 times the altitude at all times. At what rate is the height changing when it is 15 feet high? 1 second. Okay, so we'll start with a picture. We've got a cone. Then as the gravel is falling off the conveyor, the cone gets wider, it gets taller. So those dimensions are changing, which is increasing the volume at the same time too. So what we want is a volume equation for a cone, because they're giving me the rate of the volume. So volume of a cone is 1/3 pi r squared h. Now if you notice in the problem, they do give a relationship between the height and the diameter, which means we can eliminate one of these variables. So we've got, it says the diameter of the base is approximately 3 times the altitude at all times. So the altitude, remember, is just another word for height. So if I call the height h, that means the diameter can be written 3h. And now I can now write the radius in terms of the height, because they gave me that relationship, making my equation a little bit easier to work with when it comes to derivative. So the radius is going to be half of 3h, so I'll go 3/2 h, or you can put 1.5h. Okay, so I'm going to simplify this as much as I can before I jump into derivative. So 1/3 pi, squaring everything in here, I'm going to have 9/4 h squared, and still times this h on the end. I'm going to simplify the 1/3 and the 9/4. So that will give me 3/4 pi h cubed. And now I'm ready for the rate equation with respect to time. So that means the derivative of v is a 1 times by dv dt. This is a constant, it carries along. So that's 3/4 pi times 3h squared times the derivative of the height with respect to time. Okay. Now I'm ready to substitute in. Let's see what's given. Remember that 10 cubic feet per minute is our dv dt. And the height is 15. And I only have the 3 unknowns, which lets me solve for how fast the height is changing. So dv dt is getting substituted in with a 10 times 1, 3/4 pi times, oh, what did I screw that up? Oh no, 3, height is 15 squared times dh dt. Okay, with no calculator, I'm just going to multiply by 4 to get rid of my fraction. So if I multiply by 4, that's going to give me 40. And then I can divide by, this will be 9 times 15 squared times pi. Divide by 9 pi times 15 times 15. If I break it all apart, I don't have a calculator here, so that will leave me with dh dt. Let's see, 5 goes into here 8 and into here 3. And that's about all the simplifying I'm going to get. So I will get 8 over 45 times 9 is 405 pi. And if you had a calculator, you could get a decimal for that. But then the units for the change in the height with respect to time, we are looking at feet per minute. Okay, number 2. Second problem. We've got a boat is being pulled in by a winch on the dock 12 feet above the boat. The winch pulls in rope at 4 feet per second. There's a rate, it's a derivative. Determine the speed of the boat when there is 13 feet of rope out. Alright, so we've got a dock. Then we've got a winch, which is just a crank with a handle that has the rope attached to the boat. Okay, and it's being pulled in to the dock. So I definitely see a right triangle here. And what I know is the distance here, the winch it said was 12 feet above the surface of the boat. So this side of my triangle is going to be a constant 12. That's not going to grow or shrink. The rope is being shortened up. As you turn the crank, it shortens the rope up, which makes this distance shorten up. So we've got that and that. Remember, no numbers until you're all done. The variables that are, the distances that are changing, we put the variables in. Okay, so our equation then is just a Pythagorean theorem. So it's x squared plus r squared, plus 12 squared equals r squared. And there's no simplifying to do, so we're ready to find the rate equation, which is derivative, so that'll be 2x times dx dt plus derivative of 144 is 0 equals 2r times dr dt. So I need to know x, r, and one of these two rates. So let's see what's given. So the winch pulls in rope at 4 feet per second. So that's the dr dt. Looks like it's 4 feet per second. But if you remember, if your distance is decreasing, that means that the rate is negative. They're not going to tell you that in the problem. You've got to reason through that. So this rate is actually negative 4 feet per second. And then the amount of rope is 13. So I know that r is 13. I still need to know x, and I can get that with Pythagorean theorem. So, setting it up, I need to know x plus 12 squared equals 13 squared plus 144 equals 169. Do the subtracting. X squared is 25. X is 5. So now I have everything, and then that allows me, it says determine the speed of the boat. That's the change in x with respect to time. So plugging in, got 2 times by the 5. dx dt is what we're looking for. 2. The r value was 13. And then dr dt is that negative 4. So 10 dx dt equals, multiplying this out, you get negative 104. Divide by 10, and dx dt will equal a negative 10.4. And the units on that rate are going to be feet per second. So that distance is decreasing over time with the negative derivative, which it should be. Okay. Third one. We've got car A is traveling west at 50 miles per hour. Car B is traveling north at 60 miles per hour, so those are rates, those are derivatives. Both are headed toward the same intersection. At what rate are the cars approaching each other when A is 0.3 miles and B is 0.4 miles from the intersection? So we've got two cars traveling toward the same intersection. So picture first. Here's my intersection. Car A is traveling west to get there. So that means car A is over here and it's traveling west to this intersection. And car B is traveling north to get to that intersection. So that means car B is down here. Car B. And we're talking about the rate that these two are approaching each other, this distance here. So as they move, their distance is decreasing, and we want to know at what rate they're approaching each other. So this distance is going to change over time. I'll call it little a because it's car A. This distance is going to change over time. So I'll call it little b, and then obviously the distance between them is going to change. So again, we've got a nice little Pythagorean theorem. Easy equation. A squared plus b squared equals d squared. Just make sure you don't put any numbers in here that don't belong here. They're not constants. So the rates and those distances are at a specific time. They don't maintain that 0.3 and 0.4 for the whole problem. So the rate equation is coming next, which is going to give us 2a times by its rate plus 2b times its rate equals 2d times its rate. All right, now we need A, B, D, and 2 of the 3 rates. So let's go back and see what they give us. So car A is traveling west at 50 miles per hour. That's the A car. So the dA dt, again, is 50. But take a look. This distance is decreasing because it's getting closer to the intersection. So this is actually a negative 50 that you have to supply. Car B is traveling at 60. So dB dt is actually a negative 60 miles per hour. They're telling me that the distance the distance of point A, A is 0.3. So little a is 0.3 and little b is 0.4. And it's asking for at what rate are the cars approaching each other. That's this change in the distance between them with respect to time. So substituting 2 times the 0.3 times the negative 50 plus 2 times by the 0.4 times by the negative 60 equals 2. Oh, the D. I didn't find that yet. Kind of ran into a brick wall, and that'll happen. So I go back. I know that A is 0.3, B is 0.4. I can find the third side of a right triangle when I know 2 of the sides. So 0.3 squared